Distance vector routing protocol operations. Let's talk a little bit more about our distance vector routing protocols. The distance vector routing protocols share updates between neighbors, and neighbors are routers that share a link and are configured to use the same routing protocol. That's important, it has to be the same routing protocol. The router is only aware of the neighbor addresses of its own interfaces and the remote network addresses it can reach through its neighbors. The routers then are going to use distance vector routing, are not aware of the network topology. They just know the IP addresses and the interfaces. Some distance vector routing protocols send periodic updates, which takes up overhead. An example of that would be RIP sends a periodic update to all of its neighbors every 30 seconds. RIP does this even if the topology hasn't changed since the last time it sent one. So you can see that this is going to add some overhead. It continues to send updates. With RIP v1, it reaches all of its neighbors by sending updates to all the host IPv4 addresses of a 255.255.255.255, which is called a broadcast. And the broadcasting of the periodic updates is inefficient because the updates consume our bandwidth. So the more bandwidth we use, the slower our network can be. RIP v2 and EIGRP instead use multicast addresses so that only neighbors that need updates will receive them. EIGRP can also send a unicast message to only the affected neighbors. Also with EIGRP, it will only send an update when needed instead of periodically. Now with our distance vector routing protocol, at the core of it is the routing algorithm, and it's used to calculate the best path and then send that information to the neighbors. So the algorithm used for the routing protocol defines the following processes: the mechanism for sending and receiving your routing information, the mechanism for calculating the best paths and installing routes in the routing table, and mechanisms for detecting and reaching and reacting to the topology changes in case something does change. Different routing protocols use different algorithms to install routes in the routing table, to send updates to the neighbors, and make path determination decisions. An example of this is RIP uses the Bellman-Ford algorithm as its routing algorithm. It's based on two algorithms developed in 1958 and 1956. And then EIGRP and EIGRP use the diffusing update algorithm or dual. Let's look first at RIP v1 versus RIP v2. Remember, RIP v1 is the legacy RIP protocol. The metric both use hop count as a simple metric, and the maximum number of hops allowed with RIP protocol is 15. If it's going to go beyond 15 hops, it's going to drop it. It updates and forwarded to addresses. For RIP v1, it's going to go out of the broadcast 255.255.255.255. With RIP v2, it's going to use a multicast of 224.0.0.9. RIP v1 does not support VSLM, CIDR, summarization, or authentication. However, RIP v2 will support these, because RIP v2, remember, does go with classless. RIP updates are encapsulated into a UDP segment with both source and destination port numbers set to UDP port 520. And remember, it does have a 15 hop limitation. It also has an administrative distance of 120. Now looking at IGRP versus EIGRP. With both of them, the metric use a composite metric consisting of bandwidth and delay. Reliability and load can also be included in the metric calculation. With IGRP, it does a broadcast message to update, and when it forwards these addresses, and then the EIGRP uses a multicast. IGRP does not support VLSM, CIDR, summarization, or authentication, where EIGRP does. EIGRP introduced what's called bounded triggered updates. It does not send periodic updates, only routing table changes are propagated whenever a change occurs. So it doesn't constantly send out updates. It has a hello keep alive mechanism. It's a small hello message, is periodically exchanged to maintain adjacencies with its neighbor router so that it doesn't drop it. This means a very low usage of network resources during your normal operating time. Instead of the periodic updates, it just says, hey, I'm still here. It maintains a topology table. It maintains all these routes that are received from its neighbors, not only the best path, it keeps up with all of them, in a topology table. And Dual can insert backup routes into the EIGRP topology table. It has rapid convergence, and it has multiple network layer protocol support. So EIGRP uses protocol dependent modules, which means that it is the only protocol to include support for protocols other than IPv4 and IPv6. It can support IPX and